Now that we've got our definition of the derivative down, we're going to practice by computing the derivative of three different functions. Each has its own little technique to compute it. First one we're going to try is another quadratic, but it's got more than one x in it. So f of x is 2x squared minus 4x plus 3. Use the definition of the derivative to find f prime of x. And one thing to note is that if you already know some shortcut to find these derivatives, that's great, and we're delighted for you. But for now, we want to be sure that we know how to compute these from scratch. We want to understand where the derivatives come from, not just having memorized some formula. Starting in week 5, we will come up with all of the formulas and understand where those formulas came from, and then we'll be able to use the formulas. But not until we do that will we be able to use those shortcuts. So all of these start the same way, of course. They all start with our definition. Limit as h goes to 0, f of x plus h minus f of x over h. Often the place where people are most likely to go wrong in these problems is in the very next step, which is they put the h in the wrong place. So I would suggest pause the tape for a second here, see if you can write out the next line, see where the h is supposed to go, or if there's more than one h. So what are we doing now? When we plug in f of x, when we plug in x plus h, what is this going to be? So 2x squared, we're going to get 2 times the quantity x plus h squared. Because whatever we feed this function, it squares it here. So if you say, what is f of pi? It's 2 times pi squared minus 4 pi. If you say f of blueberries, it's 2 times blueberries squared minus 4 blueberries. So if you say, what is f of x plus h? It's 2 times x plus h squared minus 4 times x plus h. So the x plus h has to go in both of those places, because that's the job of this function. Whatever you feed it right here, it puts that same thing here and here. So if we're feeding it x plus h, it's going to put an x plus h here and another x plus h there. And these parentheses are important, of course. And now we want to do minus f of x, so minus this whole thing. So minus 2x squared minus 4x plus 3 all over h. Do you like the way that's written? Are any of you feeling a little nervous? You should be. What's wrong here? We want to be subtracting all of f of x. If I write it like this, though, I'm not going to get the signs correct. We're supposed to be subtracting that entire quantity, so we need parentheses there to remind ourselves of that. So again, parentheses are important. Now we're going to have to multiply this all out and hope that things cancel as they did in our previous example. So if we do x plus h squared, we get an x squared plus 2xh plus h squared. That all gets multiplied by 2. So 2x squared, 2 times the 2xh, which is 4xh, and then 2 times the h squared, which is 2h squared. And you'll notice that we know that we need to get to a point where every term in the top has an h in it, so we can factor out an h and cancel the h in the bottom. So as soon as we see this 2x squared here, it doesn't have an h in it. We know there better be a negative 2x squared coming somewhere down the line to cancel it out. Now this negative 4, we get negative 4x. And then what should it be? Should it be plus 4h or negative 4h? It should be negative 4h, because this negative carries along. And since this negative 4x didn't have an h in it, we know that we've got to find a 4x later on to cancel that. And then the plus 3. And now we put this minus in, and we distribute the minus sign. The minus minus 4x becomes plus 4x. That's good news. We were looking for a 4x to cancel that. And this 3 becomes minus 3. And this is all still over h. And so now we're hoping that enough things will cancel that every term in the top has an h in it. So the 2x squareds cancel. That's good news. The 4x's cancel. That's good news. And the 3's cancel. That's good news. So at this point, you should ask yourself, once you've canceled everything, does every term in the top have an h in it? If you find that you have a term in the top that doesn't have an h in it, then you know something has gone wrong, and you should go back and check. And probably what went wrong was something with parentheses or not distributing a minus sign. So now we can factor out the h from the top, as we are hoping to do. So this 4xh will become 4x. 2h squared will become 2h. Minus 4h will become minus 4. And that's all the h's that we had. So now finally, we can cancel these h's. So we're not in danger of dividing by 0 when we plug in h now. So we get 4x plus 2h minus 4. And so now we have to just let h go to 0. So when h goes to 0, what happens to 4x? 4x just stays 4x. 4x doesn't care what h is doing. 2h will become 2 times 0, which is 0, and then minus 4. So that is f prime. So that will tell us the slope at any x value we want. So if you plugged in 5, 4 times 5 minus 4 is 16. So that tells you the slope of this curve at x equals 5 is 16. Now let's use this definition to do something interesting, maybe interesting. So at what x value does f have a horizontal tangent line? So a horizontal tangent line will look like this. So what should the slope of a horizontal line be? It should be 0, right? So this formula tells us the slope at any given x value. So we want to solve that equaling 0. So we want to set 4x minus 4 equal to 0. If we bring the 4 to the other side, 4x equals 4. So x equals 1. So we have an applet for this function. You can confirm this, play around with the applet. You should see that by sliding the tangent line around on the applet, when you get to x equals 1, the slope of the tangent line should be perfectly horizontal, which should confirm what we have figured out here.